Hey everybody, welcome back to the Teach Back Method, where I teach you guys something I'm learning about in grad school to help me learn the concept better. As you can see, we still have our template up here, so we're going to be continuing with one of our ascending tracts of the spinal cord. Today we're going to be discussing the trigeminothalamic tract. Alrighty, as you guys can see, our original template is up here, but I have added some additional things for this tract. I know there's a lot going on, but we're going to break it down and everything's going to be okay. So as usual, we have our cortex, midbrain, pons, medulla, thalamus, globus pallidus, spinal cord, and the levels of the spinal cord, which are not as important for this tract. The additional things that I have added here are our sensory inputs and some nuclei. So let's talk about these for a minute. So when we think about our trigeminothalamic tract, what nerve do you think is really important? Trigeminal nerve. So right here, this big area, our information comes for the trigeminal nerve. This area right here is our trigeminal ganglion, and then these are additional sensory inputs from other cranial nerves. So we have 7, 9, and 10, and then there are two nuclei that are really important for this tract as well. So this one right here is our chief sensory nucleus, and this long guy right here is a nucleus. That is our spinal trigeminal nucleus. I'm gonna warn you guys, jump scare. This is our trigeminothalamic tract. I know it's very busy, there's a lot going on, but we are going to break it down piece by piece so you guys can better understand it. So, what does the trigeminothalamic tract do? What kind of information does it send? Where does it come from? Where does it go? So, the trigeminothalamic tract carries sensory information about discriminative touch, proprioception, pain, and temperature from the head, face, and oral cavity. Now, the way I kind of like to think about it is that information is kind of a mixture of the DCML and our spinothalamic tract. So the types of information that it's carrying, it's kind of both, right? And it's coming from our head, face, and oral cavity. So that's why we're not focusing down here, because we're not getting information from our lower extremities, stuff like that. So that's why everything is really focused right in here. Now, this is also a 3-order neuron chain. So let's point out where those are. So our 3-order neuron chain starts here, so we have 1, and then 2, 3. I'm going to talk about where the first, second, and third order neurons are, where the cell bodies are, where they synapse, where they terminate, etc. So a big thing about the trigeminothalamic tract is it is considered one tract, but there's actually 2 pathways. So we do consider this overall an ascending pathway, but some of our information actually descends before it ascends. So that's why things are looking a little crazy. So we think about this as our starting point, right? Our trigeminal nerve. Think trigeminothalamic tract, trigeminal nerve is where it starts. So most of our cell bodies for the first order neuron are right here in our trigeminal ganglion. Now some of them go up and they synapse in our chief sensory nucleus, and others go down to synapse all along the spinothalamic nucleus. So that's where our first order neuron is. Our second order neurons start all on the spinal trigeminal nucleus. The information crosses at various points, and they go up, and overall they synapse on the VPM of the thalamus. Now, please don't confuse VPM and VPL of the thalamus. So the VPLs is the location for our DCML tract and our spinothalamic tract. But here it's VPM, so that's important differentiation. And then our third order neurons go from our VPM up to synapse in our cortex. Now, once again, think about the types of information. So everything is just going to our face regions. It's not going anywhere closer to that midpoint, because we're just talking about information from the head, face, and oral cavity. So that makes sense. About lesions next. Now, same concepts as our previous videos. If there is a lesion in our first order neuron, it's on the ipsilateral side. Why is that? Because the first order neuron never crosses. It doesn't cross until we get to our second order neuron. So if there is a lesion in our first order neuron here, then the defects would be on the ipsilateral side of the face. So loss of pain, temperature, proprioception, etc. on one side of the face, the same side as the lesion. Now, if there were lesions in the second order neuron, it would be the contralateral side. Why is that? Because it is already crossed. So the information that would be impacted would be the contralateral side of the body. The last thing I want to point out is our midbrain area. So once we're at the midbrain area, all of the information is traveling together. So we don't have any more of this distraction down here. All of the fibers are running together in the midbrain. So if there was a lesion in our midbrain area, that would mean that there is a global loss of this information because all the fibers are traveling together, all of them would be lost. Thanks.